When you hear the words software engineering, what comes to mind? Probably lines of code, complex algorithms, maybe even servers humming away in a data center. But, that's really just scratching the surface. The real story of software is so much more interesting. It's a story about people, about massive engineering challenges, and about how this one field has completely reshaped our world. So let's pull back the curtain and see what's really going on.
We're starting with this quote because it gets right to the heart of everything. It basically says, the problem with software engineering isn't technical, it's human. And that just completely flips the script, right? It suggests the biggest, most stubborn bugs aren't in the code, they're in us.
Okay, so let's dig into that. This human problem. What does it actually look like when you're on a team trying to build something?
Have you ever used an app that you loved, and then an update comes along, and suddenly it's slower or clunkier, or a feature you used all the time is just gone? You probably thought it was just a technical glitch, but a lot of the time, the real reason is purely human. It's the friction that happens when you put a bunch of really smart, passionate people in a room together, each with their own ideas, their own ambitions, and their own egos.
And when you look at the specific ways this happens, it becomes painfully familiar. You've got the person who loves to point out what's wrong but never offers a better way. The developer who wants to scrap a perfectly working system just because they want to use some new, shiny technology. Or, and this is a big one, teams getting so lost in technical arguments that they completely forget who they're building this for, a real person. This is the kind of human chaos that can absolutely sink a project.
So how in the world do you manage all this chaos, both the human and the technical kind? Well, that's exactly why the discipline of software engineering was invented. It was created to bring some order to all of this complexity.
The real power of this definition comes down to 3 words: systematic, disciplined, and quantifiable. See, this isn't about just sitting down and creatively coding until something works. It's about building reliable, high-quality software in a predictable way. Kind of like how a civil engineer would build a bridge that they know won't fall down.
And this discipline wasn't just invented for fun. It was born out of a total crisis. Back in the 60s and 70s, as computers got more complex, software projects were failing at a shocking rate. They were wildly over budget, years behind schedule, and the final product was often buggy and unreliable. So software engineering had to happen. It was a necessary response to stop the bleeding and start building things that actually worked.
At the core of this disciplined approach is a roadmap called the Software Development Lifecycle, or the SDLC. It's a way to break down the huge, intimidating task of building software into smaller, logical steps. You start by figuring out what the user actually needs, all the way through designing it, building it, testing it, and then keeping it running after it's out in the world.
And this next slide, this is a perfect example of how things have evolved. Today, security can't be an afterthought you tack on at the end. As this diagram shows, there's a whole parallel process for security, the SSDLC, that runs alongside every single step. From looking for threats in the design phase to running security tests later on, it's all about building security from the ground up.
Now, when this process is done right, wow, the results are nothing short of world-changing. Seriously, well-engineered software has become the engine that drives our entire modern society.
I mean, just look at these examples. Tesla isn't just a car company anymore. It's a software company on wheels. Their ability to update cars over the air completely redefined the auto industry. Amazon's logistics software turned e-commerce on its head, and Netflix's recommendation engine, well, it killed the video store and created the streaming world we live in. That is the incredible power of software.
But, and this is a really big but, with that kind of transformative power comes an enormous, enormous weight of responsibility.
Think about it. When the code you write can affect millions, even billions of people, every single decision you make becomes an ethical one. As this quote says, professionals have a massive responsibility when they're designing systems that directly impact so many lives.
And these are not abstract academic problems. We're talking about very real issues. Like, how do we keep our personal data safe? How do we stop algorithms from making biased decisions about who gets a job or a loan? And how do we design platforms that don't become fire hoses of misinformation? You can see how this all loops right back to the beginning. These aren't just technical mistakes. They are fundamentally human problems that come from not thinking about the real people on the other side of the screen. So the big takeaway here is that you can't just patch these ethical problems with another line of code. The solution has to be a fundamental cultural shift. It means making ethics a core part of how we train engineers and how they think about their work every single day. Okay, so with all of those challenges in mind, where do we go from here? What does the future of software engineering even look like?
Well, the pace of change is accelerating like crazy. Take AI, for instance. Not that long ago, it was mostly about automating simple, repetitive tasks. Now, we have generative AI that's helping discover new medicines, create personalized lesson plans for students, and completely optimize global supply chains. It's just a tiny glimpse of the power future engineers are going to have at their fingertips.
And the scale of this future is almost hard to get your head around. The market for the Internet of Things, connecting everyday objects to the Internet, is projected to hit almost $1.4 trillion. At the same time, things like robotic process automation are also exploding. It all points to a future that's more connected and more automated than we can probably even imagine right now. So, what skills will this future demand? You might expect a list that's pure tech, but look closer. Right next to AI and cybersecurity, you see things like analytical thinking, resilience, and flexibility. The engineer of tomorrow can't just be a tech wizard, they also have to be an adaptable, critical thinker, a human.
And here's the kicker. This challenge isn't just for engineers. The World Economic Forum predicts that to stay competitive, nearly 60% of all workers are going to need some form of retraining. In a world that is completely run by software, learning can't be something you just do once. It has to be constant. Which brings us right back to our final question. We started this journey with the idea that software is fundamentally a human problem, and we end here. All of this incredible world-changing technology is, at the end of the day, just a tool. And it leaves us with a choice. Are we using that tool to build a future that is not only more efficient, but also more fair, more equitable, and more just? The answer to that? Well, that's going to be written in the code of tomorrow.